Okay guys, I figure for quiz 1 in Calc BC, I would do this for you since we didn't really get the chance to do that today in class. But this is what I was planning to give you in class. So the quiz is on sections 5.1 through 5.3. Your best bet is to go through the notes and redo examples. And then of course the next thing is the homework problems. At least, one or two problems from each section. Make sure you know how to do not just, number 14 out of 13 through 16. Do 2 different types of problems from that section of homework. Alright, so really quick, section 5.1 was all about the rectangular approximation method. And just make sure that you know how to find the LRAM, RRAM from a table. Okay, and if you were given a graph, so from a graph, finding the MRAM. Okay, that's basically all from section 5.1. 5.2 was the Riemann sum and then putting it together to integral. So taking the Riemann sum, which is basically the same thing as saying, rectangular approximation method, but giving it a notation, and then rewriting that into integral notation. So make sure you know how to go from the Riemann sum notation to the integral notation. Examples are like from page 267, 1 through 6. Alright, evaluating an integral of a constant. So from 0 to 2 of 5 dx. Do you know how to do that? Graphically or just integrating. Evaluate the integral of a linear function from 0 to 2 of 3x dx, or 3x plus 2, okay? And then the polynomial, 0 to 2 of 3x plus 2x squared plus 4 dx. Okay, so evaluating the definite integral. Some examples of those for the constant, if you remember, was on page 267, 7 through 12. Okay, and remember that you're not just going to be evaluating them algebraically. You're also going to be evaluating them graphically. So algebraically or analytically, whatever you want to call it, or graphically. So taking the function, the linear function, graphing it, and then from the graph finding the integral, the area under the curve. Okay, so make sure, since you know you have to do it graphically, make sure that you are able to recognize different graphs. Okay, this comes from page 267, 13 through 22. Any one of these is fair game, guys. Okay, so some examples are semicircle. So if you had to estimate the integral or find the area of a semicircle, you know that it's half of pi r squared, right? Or an absolute value function or linear function. Okay, so these are some of the examples from 13 to 22. So integrating using the graph. and using the geometric formula for area. That's basically it from 5.2. And then 5.3, if you remember there's the rules for definite integral. It was from the table or in your notes on page 269. Some examples like page 274, 1 through 3, or of course 4 or 5, I mean, but those were just some of the ones. The average value of a function, which was ab of f, is equal to 1 over b minus a of the integral from a to b of f of x dx. And remembering that that is equal to the mean value theorem of integrals, which basically is equal to f of c. So this guy right here can be written for this or this. Okay? So remember that the average value of a function is equal to f of c, and then you can use this to find c. And then the last thing was what we were covering today, and that was total area and net area. Just keep in mind that total area cannot be negative or a 0, because you're going to basically always be adding up the areas, and even if the area is technically a negative value, you're going to add the positive of that. Okay? So you're going to take the absolute value of any negatives. And then the net area, it can be negative or even 0. Okay? And remember, for net area, let's just use this as an example. So if this is 0, 2, 3, for the net area you can find the integral from 0 to 3 of that function, all of it, and it will give you all the areas as it's supposed to be. But for the total area, you're going to have to split this up and say it's 0 to 2 of f of x dx plus this little part, which is the integral of 2 to 3 of f of x dx, but you have to make sure that you take the absolute value. And the reason we're taking the absolute value of this part is because it is negative. Okay, so use the example from the notes. And then make sure, you know, we never really went over, but page 275, number 29, graphing a piecewise function. Graphing a piecewise function and then finding the area. So we did this in class. If you have a function that kind of, you know, let's say it did one of these, could you find the area from -2 to 2? Remember the discontinuous? So remember, you find, basically you have to split these up and figure out the area up to this point using probably a triangle. Now you're going to get a better looking graph, and then find the area of this section right here. Okay? So you find the area of this, probably splitting it up, triangle, rectangle, rectangle, adding them all up. All right, hope this helps and hope you guys aren't freaking out. It's supposed to be an easy, the Monday test is going to be the multiple choice. It should not take all hour, and then Tuesday we'll do the free response section. All right, enjoy.